Hello everyone, my name is Nikita and I'm from the Bodhi Academy. In the last video, we had started with the chapter from 9th standard science textbook, chapter number 4, the structure of atom. Okay, and we saw some contributions of some scientists in deducing the structure of atom. Today we will be moving on further and we'll be studying the more contributions about the structure of atom, and finally we will see what is the most accepted structure of atom which we use. Okay, so to start with, first we have to study what the remaining contributions of some of the scientists. Okay, so last time we had seen the J.J. Thomson's model, then Rutherford's model of atom. Today we are going to see Bohr's model of an atom. Now just a flashback, we have to remember that what the Rutherford's model was and why it was not accepted. If you all remember, the Rutherford's model said that electrons revolve around the nucleus, okay, and it was not given how they revolve. So there was a drawback in this model that the electrons would revolve and accelerate, okay, and then they would radiate energy and fall into the nucleus. In that case, the atom will be quite unstable, so it was not accepted. That's the reason another scientist, the Neil Bohr, okay, he put forward some of the following postulates about the model of atom. Now let's see what were his postulates. The first postulate was electrons revolve around special orbits known as discrete orbits, which are allowed inside the atom. Okay, now what does this mean? By this he means that electrons, now we know that there is a nucleus in the atom as found by Rutherford. Okay, he said that electrons revolve around an orbit, around the nucleus in an orbit. So for suppose this is an orbit, a discrete orbit inside the atom which is around the nucleus, okay, and electrons are moving in this discrete orbits. Okay, now so he said that that electrons follow a particular orbit, a particular path in which they will revolve. The first postulate says that, and the second postulate is like the continuation of the first one. It says that while revolving in the discrete orbit, they do not radiate energy. They do not radiate energy. Okay, so if they are revolving in discrete orbits, they will not radiate energy. But in case of Rutherford model, there was no discrete orbit. They were just revolving around the nucleus. In that case, they will radiate energy, they will fall into the nucleus, and that would be unstable. But over here, when they are moving in a discrete orbit, they do not radiate energy, so they will not accelerate, okay, and they will make the atom stable and not unstable. Okay, so these were the postulates put forward by Neil Bohr. Okay, now let us see what were those discrete orbits. So he called this orbit as energy levels. So there are some names for that orbits. First of all, you can call them orbits or shells, or they are called as energy levels. Now what does this mean, energy level? Energy level means they are of particular level of energy. Okay, everyone will have a particular level of energy. So he said that there are 4 shells: K shell, L shell, M and L shell. Okay, and each had a level of energy. K shell had the lowest level of energy with n equals to 1, L shell had n equals to 2, M shell had n equals to 3, and N had n equals to 4. Okay, so these were the energy levels of K, L, M and shells. Okay, now the orbits are represented by the letters K, L, M, N, or the numbers 1, 2, 3 and 4, which represent the energy levels. Okay, so for now we just need to remember that there are these orbits which are present outside the nucleus. Okay, before going on further to understand what is the significance of these orbits in carrying the electrons, we will be studying another subatomic particles. Now when we were talking about subatomic particles, we have studied two subatomic particles as of now, which were the protons, which have a positive charge, okay, and they have mass, okay, and then we studied the electrons, which are negatively charged with no mass or negligible mass. Now another scientist, J. Chadwick, he discovered another subatomic particle which had no charge. Okay, no charge means it was considered to be neutral. Okay, neutral. So it was named as neutron. Okay, from that the name came the neutron. But it did not have any charge, but it had mass equal to that of the proton. Okay, it had mass equal to that of the proton. In general, a neutron is represented as n. The mass of an atom is therefore given as the sum of the masses of protons and neutrons present in the nucleus. Okay, so the next subatomic particle which J. Chadwick discovered was neutron, which had no charge but it had mass m, so same as that of the protons. Okay, and neutrons was represented by letter n, and it was discovered by J. Chadwick. Okay, now where was this neutron present? The we have seen yesterday that the the nucleus, okay, the nucleus is present in the center of the atom. Okay, and now we saw that electrons revolve in discrete orbits outside. Okay, and also we had seen yesterday that protons are present inside the nucleus. Now these neutrons are also present inside the nucleus. So inside the nucleus we have the protons plus the neutrons. Okay, so now we know that the electron doesn't have mass. Okay, but we have learned that the protons and neutrons both have mass. Okay, both have mass. So total mass of an atom, okay, total mass of an atom is called as atomic mass, is present inside the nucleus. Okay, is present inside the nucleus because those are the only subatomic particles in the entire atom which has mass. Okay, so atomic mass is given by the number of protons plus number of neutrons, okay, which are present inside the nucleus. So mass of an atom is given by the sum of the masses of the protons and the neutrons. Okay, so this is the next discovery. So here we end the contributions of all the scientists. Now we are going to study the different energy levels and how in these energy levels the electrons are filled. Okay, now there are some rules which we need to follow while filling up the shells. Okay, so we know that there are K, L, M, N. Okay, and for K, N is equals to 1, for L, N is equals to 2, for M it is N is equals to 3, N is equals to 4. Now, how many electrons will go in the K shell is decided by the formula. Okay, there is a formula over here, that is 2n 2n raised to 2 is the formula, wherein n is the orbit or the energy level index, that is 1, 2, 3. Okay, so let us see how it is. K, so the formula is 2n raised to 2. Okay, so for K we know that 2n is 1, so the answer is 2. So 2 electrons can be accommodated in the K shell. Next L, okay, for 2 raised to 2, 8 electrons, then 2, 3, n is equals to 3, right? So 3 raised to 2, 18 electrons, and 2, 4:2, 32 electrons. Okay, so 2, 8, 18, 32 electrons can be accommodated in the K, L, M, N shells. This is the first rule. Now, the second rule is that the outermost electron, the outermost shell, okay, see, if the atomic number is, we'll consider lithium over here, if the atomic number is 3, okay, so K will take the 2 electrons and L shell will take 1 electron. Now which is the outermost shell over here? The outermost shell over here is L, right? Outermost shell is L. Now for each element, the outermost shell will be different. So the rule is that whatever is the outermost shell, may it be K, L, M, N, okay, it is L, M, N, okay. So in that the maximum number of electrons can be accommodated is 8. This rule is there, okay, this rule is there. This is for if the shell is in between, but if the shell is becoming the outer shell, then the number of electrons can be accommodated as 8, okay. So that is the second rule. Electrons are not accommodated in a given shell unless the inner shells are filled, okay. So it is like you have to fill the K shell first and then go to L shell. We can't directly put 3 electrons in L shell. It should be in a stepwise manner. So these are the 3 rules which we have to follow when we are filling up the electrons, okay. Now let us see here. Lithium I have done. Now beryllium. Beryllium has, this is the nucleus, okay, and these are the electrons. So this is the K shell, this is the L shell. Now beryllium atomic number is 4, so 2 and 2, okay. Boron atomic number 5, 2 electrons and then 1, 2, 3 electrons. Carbon is 6, so 2 and 4, okay. Nitrogen is 7, so 2 and 5. Oxygen is 8, so 2 and 6, okay. So that way the electrons are filled. Now understanding this, we will go to the next concept, that is valency. Now what do you mean by valency? Valency is the ability of an electron to have a completely filled outermost shell. Completely filled outermost shell means the shell should have 8 electrons. Outer shell will always have 8 electrons. So an atom has to have 8 electrons, okay, that is its valency, okay. If it is not having 8 electrons, it will either take electrons to complete the shell or it will lose electrons to have a outermost shell. Let us see when they lose and when they take, okay. So next concept is valency, that is ability to have a okay. Now let us see over here, okay. So starting from hydrogen, hydrogen has atomic number 1 and number of electrons will go as 1, so the valency is 1, means in hydrogen, this is the nucleus, this is the K shell, right, K shell. So now atomic number we know that it is 1, so K shell will take 1 electron. Now to have a completely filled outermost shell, the capacity of K shell is 2, right, it can take 2 electrons, but it has taken only 1. So to get a completely filled outermost shell, hydrogen has to take 1 more electron, okay. So the valency of hydrogen becomes 1, okay. Now next, Let us see carbon. Okay, now carbon has 2 electrons in the K shell and 4 electrons in the L shell. So the valency of carbon is 4. To get a completely filled outermost shell, it will either take 4 electrons or it will lose 4 electrons. Okay, now let's see oxygen. Very important, when you do this, you have to first write the atomic number of the element. That is, oxygen is 8. Then you write the electronic configuration. K shell will take 2 electrons L. Now how many remained is 6. Okay, now 6 is a bigger number, right? 6 is a bigger number. So you cannot lose 6 electrons. To complete this, you have to take 2 electrons. Okay, so the valency of oxygen is 2. Okay, now let us consider another one, chlorine. Okay, now chlorine has atomic number as 17. The electronic configuration is 2, 8, 7. Now to get a completely filled shell, chlorine will take 1 electron. So the valency of chlorine is 1. Okay, another example is sodium. Sodium has atomic number as 11. Electronic configuration will be 2, 8, 1. Okay, now this one has to take plus 7 electrons. Okay, this is the outermost shell, K, L, M is the outermost shell. So it has only 1 electron. So to make 8 electron, it has to take 7 electrons. But taking 7 electron is not a good idea because it will use a lot of energy. Okay, and we can't afford to lose a lot of energy. So that is the reason, instead of taking 7 electrons, the 1 electron is lost. Okay, 1 electron is lost. So the valency is 1. Okay, so now from this we can say that if there are 1, 2, 3 electrons in the outermost shell, they are lost. Okay, and that is the valency of what are lost. But if there are more than 4, that is 5, 6, 7 electrons, electrons are gained. Whatever, like for 5, in case of 5, 3 electrons will be gained. In case of 6, 2 electrons will be gained. In case of 7, 1 electron will be gained. Okay, 1 electron will be gained. So electrons are gained, and that is the valency. Okay, so this is important. Studying this is important, that when you lose and when you gain electrons, that becomes the valency. So you either lose electrons or you gain electrons to get a completely filled outermost shell. That is the valency or the combining capacity of an element. Okay, this is a very important part from this chapter. Okay, so today we saw what is a neutron, how electrons are filled in the energy levels, and what is the valency. Okay, so this table 4.1 is very important. This gives you an idea of all the elements and all the valencies of the elements. So in the next video we will be studying the final concepts of this chapter. So yes, thank you for watching my video. Please like, share and subscribe to our channel.